Welcome to another exciting episode of AP Chemistry here at Spain Park. Today is Thursday, November the 6th, okay, 2025, and we are talking about what's going to be on the test tomorrow. So, again, we have, ground state, just for the late arrivals here, since I started videoing late. Okay, so which one was the ground state?
Normal.
Okay, the bottom one is normal. Which one was the excited state? The middle one, because we have electrons in a higher energy level without the lower ones being filled. Outbound principle is not satisfied. Okay? Okay, so it's important to always understand that when an electron goes from, it can only go from one energy level to another, but it's a quantized, fixed. It can't just gain or lose random amounts of energy. It can't go here, because if it went here, we would see a different color. But for hydrogen, we always see the exact same colors. We never see a green or a yellow, so that's not a possible transition. Okay? So the electron can only gain. So when it goes up, here, this value, when we did it in the notes, it came out to 3.03 times 10 to the minus 19th joules. That's the energy of the photon, okay? So to go from here to here, it has to absorb 3.03 times 10 to the 19th joules, minus 19th joules. But then when it comes to goes back down, it releases 3.03 times 10 to the minus 19th joules. That's the energy of the photon. So it's got to absorb a specific amount going up, and it's going to release a specific amount coming down. It's when it comes down, it's when we see it, right? Okay, that's how all light is produced, by electrons going up and down. So right now, up in this fluorescent light bulb, you have a mixture of gases. A whole bunch of electrons are going up and coming down, and they're all giving off different wavelengths and frequencies, different size photons, and so it mixes together to make kind of a white light. All right, so which one's impossible? Okay, the top one, why? There's no 2D. Now, if we wanted to explain that in terms of quantum numbers, for a D sublevel, what does L have to equal? What does L equal for D?
2.
L equals 2. 3 is going to be F. 0 is S. 1 is P, 2 is D, 3 is F. But when, in order, but what's L, what can L only equal? From what to what? But L can only equal from, well, not form, I do that all the time, even when I'm typing. From 0 up to n minus 1. So n must equal 3, must be, let's say, greater than or equal to 3 for L to equal 2. So when n equals 2, L can't equal 2. Okay? So we do need to know a little bit about quantum numbers. Okay? So this is an impossible excited ground state.
So in excited, why didn't go to 4s2 first? Why did it go to
Again, it doesn't matter. It depends on how much energy you got put in. It can go anywhere. It should go up.
I got you.
Okay? It could possibly do that. It depends upon how much energy. It's only going to absorb whatever photons are available. It's only going to absorb the photons that give exact energy to go for to the next sublevel, to another higher sublevel, not necessarily the next one. Okay? Now, what would be the 4 quantum numbers for that electron? What would be the 4 quantum numbers for that? Okay, first off, what's n going to be? 3, because it's on the 3rd energy level. Okay, now when n equals 3, L can equal 0, 1, and 2, which means on the 3rd energy level, we can have SPD. But ours is in the S, so of course, of these 3 values, we're going to pick L equals 0. And then M sub L can only equal minus L to plus L, so it can only equal 0. What does the fact that there's only one answer mean? one way in order. So there's only one possible orbital on the s sublevel. Okay, and then m sub s, m sub l. I did it backwards. M sub l and m sub s. This is going to be, since you can either be either plus 1/2 or minus 1/2. It doesn't matter which one. Okay, that's your spin quantum number. Okay. I got my little notes here, making sure. Okay, so we need to make sure. So on the second energy level, how many sublevels are possible? 2, the S and the P. On the P sublevel, how many orbitals are possible?
3.
Orbitals. 3.
In X, Y, and Z.
Okay? Because remember, you got 1s, 2s, 2p, 3s, 3p, 4s, and then I'm going to say 1, 2, 3, 4, 5, 3d. Okay? So just as we continue on up. So we have to remember, the energy level is the 2, is the 3, it's the 4. The sublevels are s, p, d, f. The orbitals are how many spaces, how many different orientations we have. So there's always how on the s, how many orbitals are there? 1. On the p, there's how many orbitals? 3. On the d's, 5, f's, 1, 3, 5, 7. How many theoretically would there be on the G? 1, 3, 5, 7, 9. Minus 4 to plus 4. Okay? Now, again, it doesn't exist, but theoretically it does. Okay? So then how many electrons total can be in the D sublevel? Max? 10. So we need to differentiate between energy level, sublevel, orbitals, and electrons. Right? Second energy level, you have 2 sublevels. Okay? The S and the P, you have 1 orbital and 3 orbitals. Maximum of 2 and 6, or a total of 8 electrons. Okay, so just make sure we can differentiate there. All right. Then if we look at terms that we talked about ionics, atomic radius and things, the one thing I didn't point out is that if we're looking here, this is 4s1, 4s2, but then these are all going to be what? 3d. So remember that even though they fill first, even though they fill first, the 4s is going to be farther away from the nucleus than the 3d. So the electrons on the transition metals, they're all filling into that 3d, but the 4s is still out here. And then every time you add a proton, you're adding another electron, so it's kind of still shielding. So that 4s is pretty much going to stay the same. So most of these, they're not exactly the same, but their size is very similar. Okay? Because it's all, the electrons are all going into 3d, and you still have that 4s out there. So there's not a big difference in size. So transition metals pretty much carry the same, going to be about the same size. Okay? Does that kind of make sense? Because you're filling in the 3D and the 4s is still going to be out here. All right, one last thing. Well, I got 2 things, but. Do you guys remember about paramagnetic?
Yes.
Okay? So, when we're, I need to just kind of do this one down here. So if I'm going to look at carbon, carbon has 6 electrons. How am I going to fill this? Where am I going to start? 1s. How do I know that? The lowest energy. This is increasing energy. Okay? And this is going to be the Aufbau principle. And yes, you need to know these. The Aufbau principle simply says you start lowest energy and work your way up. That's the way we normally, that's ground state. Okay? So we're going to go 1, 2, 3, 4, then what? 5, where's 6 go? Here?
No.
Anywhere here, but they gotta have the same spin. Whose rule is that?
Huh?
That's Hund's rule. Okay? Now, how do I know only 2 electrons can go into any orbital? The Pauli exclusion principle. And since it's a concept, it's a principle, not a pal. Okay? Now, would this be pair or diamagnetic?
Pair, because it's unpaired electron.
Unpaired electrons. Now, if Hund's rule wasn't true, if it went like that, would that be paramagnetic?
No.
But because carbon is paramagnetic, what do we know?
Attractive.
That,
Magnetic field.
okay, but I know, but I mean, that tells me that you must have one into each, that it can't be paired up. Okay, so paramagnetic and Hund's rule kind of go together. Okay, because the fact that you put one into each tells me that you're not going to pair them up when you have 2, and because if they paired up, it would be diamagnetic, but because carbon is paramagnetic, we know it has to have unpaired electrons. What are the only groups that are diamagnetic?
Rare,
2, 12, and 18. Field S, field D, field P. Right? All right, now here is the last kind of random thought. It always goes off. And then I'm going to give you the rest of the time. Okay? For some reason or other, AP tried to just throw this in. The different types of energies are used for different identification purposes. So we have EMR in the infrared range, visible light, UV range, and microwaves. Okay? Now I'm going to just start and go up. Okay? PES, we already know about PES. I think everybody understands photoelectron spectroscopy. It says review video, but I didn't ever do a video on this. That little handout. By the way, did everybody get that handout on PES that we did? I mean, it seems like I have a bunch of extra that not everybody got one. But we all know this, so there is no video here, so don't even copy this bottom part. You know about PES. Okay? But microwaves. Okay? Microwaves are used to measure the molecular rotations. They're going to be used to determine bond lengths and bond angles. Okay, the key word here is rotation, and the way you remember this is all microwaves have a table on it that rotates when you turn it on. Okay, so microwaves deal with rotation. Microwaves, they have their little rotating table on the inside, so microwaves deal with rotation. The visible light and UV are deal with transitions, electronic energy. Well, again, this is how all visible light is produced. The electrons going up and down. So visible light is all about electron transitions. That's this stuff. Okay? And then the infrared is the other one. Okay, so if it doesn't mention these two things, then it's probably infrared. But it deals with the different types of bonds, whether it's a double bond. When you go to college and you take a higher level chemistry class, you might deal with an infrared spectrophotometer. Okay, we did a visible light spectrophotometer with the Beer's law. Okay. Ooh, that reminds me. I just ran off your test, but I wanted to include a Beer's law question on it, and I have one that I wanted to include. And yeah, that's a possibility. We'll see. But the different types of bonds, whether it's a double bond, triple bond, you can kind of get molecular structures based upon infrared. Okay, this is just straight up memorization. I'm just throwing it out there so you have a chance. Okay, so there's no explanation on that. It's just, you just know those things. Okay, I never like giving things that you have to just know, and you're not, it's way above your head as far as what they're really used for and how they're used. We don't have any of the equipment that can do any of that stuff. So that's just random potential one multiple choice question that you would have to know on that. Okay, so now you should have, you have the packet from yesterday. I told you which ones you should do for good review. And now on the Princeton review, on pages 95, 100 now, I know that I think Zayden has an older version. Okay, they're the exact same questions, just on a different page. So it's unit 3, dealing with atomic structure. The multiple choice questions are the same multiple choice questions. You just have to find what page I start on. Okay. Now I'm going to probably check these on Monday, but you probably need to have them done before tomorrow, just as far as a review. Does everybody have this copy now that wants to have a copy? That's why I turned it on. Okay. Y'all have a great day and go Jags.